Welcome to 6.3, fractions and decimals on the number line. We're going to start off with example 1, graphing negative fractions and decimals. And something I want you to think about is in 6.1 we learned that integers can be negative, but they're whole numbers. So integers are whole numbers that can be positive or negative, where fractions and decimals can also be negative, but they're just not considered integers. So we could be given the same exact type of question that we had in 6.1 where we graph each number and its opposite, but this time we're going to deal with fractions. So if I was given 3/4 and I had to graph that number and its opposite, it would look like this on a number line. I'm going to start with 0, and then I have to think about how am I going to make it equal intervals. So using 3/4, I always refer to money with different things, but $3 out of $4 looking at it in quarters would be 75 cents. So 1 out of 4, 2 out of 4, 3 out of 4. So we have to think like that if we're making equal intervals. So in this one, I'm going to make them equal intervals of fourths. I just want to point something out now that I've done them in fourths. Notice that I started at 0, and then I go to 1/4, and then it goes to 1/2. 1/2 is also equivalent to 2/4. So I still went by fourths. So I'm going to start off with graphing 3/4, and then I'm going to think about graphing its opposite. So if I think from 0, I went 1/4, 2/4, or 1/2, 3/4. So I'm going to do the same thing, but I'm going to go the opposite way from 0. So 1/4, 1/2, 3/4, and this happens to be my opposite. So negative 3/4 is the same distance from 0 as 3/4. Okay, let's try another one. This time I have graph each number and its opposite, so I have the exact same skill again, but this time I'm going to have negative 1 6/10. Again, this is not an integer, it's a number. The trickiest part about graphing fractions and decimals is making those equal intervals. Any of us can just place 1 6/10 and negative 1 6/10 on a number line and make it its opposite. But however, it's hard to do intervals. So you have to really think, what would be a good number to make equal intervals with if I'm going with 1 6 or negative 1 6/10? We could go by 2/10, or we could go by 4/10. Anything that's going to, if you think about it like 16, anything that would go into 16. So 2 can go into 16, 4 can go in 16. If you're a little confused, watch how I put it on the number line. Okay, so let me just kind of point to a couple things here. When I was saying that we could go by 4/10, so obviously I'm going to start, if I'm going to go by 4/10, I'm going to go positive 4/10, positive 4/10, positive 4/10, and so on. If you look at these numbers without decimals, that's 0 to 4, 8, 12, 16, 20, but now with decimals in them, it changes the number completely. But you can see what I'm trying to give you an example of how to make that equal interval. So look at this as a number as 16 and see how you can make equal intervals with 16. When I go negative, it's the same situation. Negative 4/10, negative 8/10, negative 1 2/10, negative 1 6/10, etc. We could look at that as negative 4, negative 8, negative 12, negative 16, and so on. So that's all I'm kind of trying to show you with that. When I'm going to graph this, I'm going to find the negative 1 6/10, and I'm just going to graph it. So that is what my answer would be looking like for that. Then I have to graph its opposite. So again, if I go this distance to the left, which is my negative distance, I have to go 1, 2, 3, 4 to the positive distance, which would be to the right. Example 2 is comparing fractions and mixed numbers. So I'm going to compare negative 1/2 and negative 3/4. So what I have to recognize is, again, I've got to make these equal intervals when I make my number line. And to do so, I kind of look at, I've got 1/2 and I've got 3/4. Remember, think of it like quarters. How could I make a whole number line full of quarters out of $1? That's the best way to look at it, and it would look something like this. Okay, so what I'm going to do is I'm going to put on my, I'm going to actually put these on the number line. Remember, going in fourths, I have negative 1/2, and I have negative 3/4. So I look at these on the number line after I graph them, and I realize that negative 1/2 is to the right of negative 3/4. So that right there tells me that if negative 1/2 is to the right of negative 3/4, that negative 1/2 is greater than negative 3/4. Don't forget, to the left, negative, to the right, positive. You get bigger if you go to the right, you get smaller if you go to the left. So this number would not be small, or it would not be a bigger number, even though 3/4 we know as a fraction is larger than 1/2. I'd rather eat 3/4 of a pizza than 1/2. But when we're talking about negatives, we have to be careful. All right, so for this one, it gets a little trickier. We're going to compare negative 5/6, negative 4 and 5/6 and negative 4 and 1/6. So now we can go by sixths on a number line. Before I even start my number line, I know that this is going to be, I'm going to have it between negative 4 and negative 5 just based on what I have up here. So that's how I started mine. I didn't start with a 0 anywhere because then you have too many intervals that you don't need. So I started with negative 4 and negative 5. I know all my data is going to be in between, or I should say, just my numbers. All right, a couple things I want to point out real quick. So I started with negative 4, then I realized negative 4 and 1/6 would be my next best guess here because I'm going to go in intervals of 1/6. I have negative 4 and 2/6, negative 3 and 3/6, or negative 4 and 3/6, negative 4 and 4/6. All three of these can be reduced. In this case, you can leave them like that to find out what the best scenario is for what you're doing. So in other words, this one should be negative 4 and 1/2 because these two equal each other. However, you don't need to write that on your number line if it helps you and guides you to where you need to go. All right, so the next thing is we got to compare them, so we have to put them on the number line. Negative 4 and 5/6 is right here. And then negative 4 and 1/6 is right here. So looking at them, we know that negative 4 and 5/6 is to the left of negative 4 and 1/6. Okay? So here is negative 4 and 1/6. To the left of it is negative 5 and 5/6. So what that tells us is we would write as an answer, if we're going to compare them, negative 4 and 5/6 is less than negative 4 and 1/6. And this would be my final answer. All right, so example 3 is comparing decimals. We're going to compare negative 3 and 8/100ths and negative 3 and 8/10ths. Just like with fractions, when I put my number line out there, I know that these two numbers are between negative 3 and negative 4. So that's where I'm going to make my intervals. Now, well, that's where I'm going to put all my intervals at. We just have to figure out what's the best place to to do our intervals in. So the best thing is to look at this one. So we go by we have 8/10ths. We know that 8/10ths is larger than 8/100ths. So we need to look at what is our best option. I would say to go with tenths. So make our intervals in tenths. So it would look like this. So what I did here, I just want to point out, when you're dealing with this and I'm looking at your work, I don't want all these numbers to merge together. So what I did was I put negative 3 in the bottom. I actually shouldn't have done this one. I should have went the opposite way, but that's right. And then once I started my intervals, I had negative 3 and 1/10. Then I went negative 3 and 2/10, negative 3 and 3/10. I just wrote the numbers up and down, so that it would be easier for me to read. There's no rhyme or reason to it. It makes no difference with your number line. If you can handle it and you have it big enough where you can put them all down there, you may. Just be careful because we're dealing with decimals. Fractions, it's a little easier to keep on the bottom, but just so you know. All right, so now we need to compare these two. So what I'm going to do is I'm going to put them both on the number line. So start with negative 3 and 8/100ths. Well, we don't have that on there. But what we do need to recognize is that negative 3 and 8/100ths is going to be between negative 3 and negative 3 and 1/10. So in other words, think about negative 3 and 9/100ths. What comes after that? negative 3 1/10. So we know it's going to be about right there. So this is negative 3 8/8. Negative 3 8/10 is way over here. So what we can conclude from this is that negative 3 8/8 is to the right of negative 3 8/10. So my answer would look like this. Negative 3 8/8 is greater than negative 3 8/10. That one's a tough one, so you got to really be careful of your intervals. All right, example 4, our real-life application. It says, a Chinook wind is a warm mountain wind that can cause rapid temperature changes. The table shows 3 of the greatest temperature drops ever recorded after a Chinook wind occurred. On which date did the temperature drop the fastest? And then it says to explain. So what we can notice here, let me get my red color here. What we can notice is that they give us this nice little table here, or table over here, picture over here. And it says on the date of January 10th of 1911, the temperature change was negative 3 1/10 degree Fahrenheit per minute. On November 10th, 1911, it was negative 5 5/8 degree Fahrenheit per minute. And January 22nd of 1943, it was negative 2 1/5 degree Fahrenheit per minute. So if they give you data like this, your job is to put it on a number line first of all. So looking at our intervals, we've got 1/10 here, we got 5/8 and 1/5. We need to figure out where the best place of intervals would be. Sometimes it's easier just to think, okay, we got fractions, let's just go by halves or quarters, 1/4, right? To make it make it where we can fill it in the best. So what they did was they graphed the numbers on the number line. They started with 0, and they ended with negative 3 1/2, because we don't go any higher than that, or any lower than that, I should say, because we start at negative 3 1/10. So this went in intervals of negative 1/4, negative 1/2, negative 3/4, negative 1, and so on and so forth. To figure out if negative 5/8 goes after, before, or to the left or to the right of 1/2, you've got to compare. You've got to make those equal fractions. Or, I'm sorry, make the denominators equal. So if I have 5/8, if I have 8 on the bottom here, and it used to be 2, what did I do to get from 2 to 8? Well, we multiplied it by 4. If I'm going to do that on the bottom, I'm going to do it on the top. 1 times 4 is 4. Is 5/8 to negative 5/8, I should say, sorry. Is negative 5/8 down to negative 4/8? Like, where does it go, left or right? So we're saying that this equals negative 4/8, this equals negative 5/8, so it's going to go to the left. Okay, so this gets tricky. This is probably one of the hardest sections you'll do in this chapter because of the fractions and the decimals and figuring out intervals. So really do your best. So what we're realizing here is once we get everything on our number line like this, it's asking us on which date did the temperature drop the fastest. Well, we want to say which one is to the farthest left of the number line. Negative 3 1/10 is the farthest to the left. So the temperature dropped the fastest on, where's my 3 1/10? On January 10th of 1911. Okay. This one's a little bit confusing. Hardest part right here, putting it on the number line. Take your time, figure it out. It does take a little bit of extra work like this. I'd be happy to help you with this if you're still a little bit confused. All right, here are your try-its. This box is where we're going to need a greater than or less than symbol that I want you to compare them. So you're going to compare these 3. Remember, your first step is to put them on a number line and then do that comparison. Go ahead and pause it right now because I'm going to put the answers on right after this. All right, write down any questions that you might have with this section because it was a little bit difficult. You're all set.